Okay, this video is going to be about adding vectors mathematically. So before we get started, here's what I want you to do. There are three vectors shown here. We've got E, L, and G here. And what I want you to do is to determine the components of each vector shown. Pause the video and see if you get the answer right. Okay, so for the vector E there, the E of x is going to be 5.02 units with a y unit of 2.9. For L of x, we've got 5.8 units, and then for the y component, it's a negative 3.35 units because it's going down. It's going over to the positive and down to the negative. For G, though, because G has 8 units and it's going horizontally, it has no y units. So what we're going to do in this video is we're going to add vectors mathematically using what's called the components method of vector addition. So let's get started here. When we're adding vectors mathematically, there's going to be 5 steps that I want you to do. Okay? If you follow these 5 steps, you'll have no problems with adding vectors. Okay? Step number 1, you're going to create a data table, and there's going to be 3 columns in that data table. The first one's going to be the vectors. The second column is going to be your x components of those vectors, and the third and final column is going to be the y components of those vectors. Okay? Then you're going to add your x and y columns together. Step number 3, you're just going to take and draw your resultant vector based on your new x and y coordinates. Number 4, you're going to use the Pythagorean theorem to find our resultant magnitude. And finally, we're going to use our inverse tangent function to find theta. So let's start here. So I've got 2 vectors. I've got D and G. G is going up and G is going over. So pause the video, add in your components, and add in each column and see what you get. Well, there you go. So we've got D, because it's going straight up, it has 0 x components, but a y component is 8. For G, on the other hand, it does have an x component, but no y component. And when I add up both of these together, what I get is an x component of 8 and a y component of 8. Let's move on to step 3 here. Do you remember step 3? Well, step 3 means we're just going to take these 2 vectors, or these 2 components, and create a new vector. So we've got G going over 8 and D going up 8. So now we have our resultant vector. We've drawn that here. Step number 4 means we need to get the magnitude of this guy. So we've got one side here and one side here. So we're going to use the Pythagorean theorem to get that magnitude. And here it is. So it's going to be c squared is equal to a squared plus b squared. And if you take the square root to both sides, the resultant vector, the magnitude becomes the square root of 8 squared plus 8 squared, or 11.31 units. That's going to tell us how long our vector is. And the last and final step is going to be able to use the inverse tangent to give us our angle theta. So we've got our angle theta here. We've got an opposite side and adjacent side. So I'm going to use tangent of my opposite of 8 units, my adjacent of 8 units, and when I plug this in my calculator, I get an angle of 45. And this is a special triangle, which tells us we have 2 sides that are the same. We've got a 45-degree angle there. Okay, so for the next one, I want you to pause the video, and I want you to go through all 5 steps. So hopefully you wrote this down in your notes. Go through all 5 steps and then start the video up to see if you got these correct. Now before you get started, let me give you a little bit more help here. This 2 in front of the D does not mean anything except for the fact you're just going to multiply this 8 by 2. This 0.5 times G here just simply means I'm going to go ahead and multiply 8 by 0.5. The negative simply means this vector is now, instead of pointing this direction, it's going to go and point the opposite direction in the negative direction. So pause the video, see what you get, and compare your answers with mine. Okay, there you go. You get a negative 4 and 16. Adding the 2 vectors together and using the Pythagorean theorem gives us a magnitude of 16.49 units. And then finally, using the inverse tangent is going to give us our answer of 75.96 degrees. Next example. Okay, keep in mind that this L vector is going to go over, so it's going to have a positive x component, and down, which means it's going to have a negative y component. There we go. So you should have a resultant x component of 7.62 with a y of 1.4, and our resultant magnitude is going to be 7.75 units with an angle theta of 10.41 degrees. Last example. Don't get intimidated here. This is basically using everything we've learned so far. We've got a negative, which means that L is going to go point upwards. And we've got a 2 in front of the F, which means I'm going to go ahead and multiply this 9.9 by 2. Pause the video and see how you do. Okay, there you go. Those are my values here, ending up with a resultant magnitude of 25.07 units and an angle of 53.88 degrees. Okay, so let's quickly review here. When we're adding our vectors mathematically, we first want to create a data table of our vectors, x and y components. Next, we want to add our x and y columns down. From those two columns, we're going to generate a resultant vector. From that resultant vector, we use the Pythagorean theorem to find the magnitude of that resultant. And finally, our inverse tangent function to find theta. So, today in this video, what we did is we added vectors mathematically using the components method of vector addition.